Hey guys, so just have a little unboxing here. It's a relatively large package. Here's like, okay, you guys really can't see it. It's try to zoom out as far as I can. It's about messy, but we're gonna open this package here. This is chemicals, not elements this time. But here we go. So we're gonna open one of them first, and then open the other one second. Ooh, that's a little bit scary. Okay, so first we have 1,4-dioxane in this package here. You can see the fire diamond there. 231. Okay, that's not awful. And there's a big old flammable sticker on it. Okay, so we're gonna get this open here on camera. I don't usually do it on camera like this, which I definitely should start doing. You know, keeps the attention span and everything. So here, we're gonna take out the bag, or at least try to. Okay, and then we're gonna cut off this tape. This is gonna be kind of hard because I don't actually have a knife with me in my room. I definitely should get one though, because that would make all of these unboxings far easier. This stuff is on pretty good, wow. Well, it's nice to know that none of this stuff is just gonna open, so. Does this have any on it? It doesn't look like it has any tape on it. No, it does. This is, I'm so sorry, guys. I might actually just cut part of this out because this is a pain in the butt to open. But I think we've gotten it now. Okay, so in here should be 30 milliliters of 1,4-dioxane right there. So 1,4-dioxane, I bought it because number one, it's just a cool chemical, and number two, 1,4-dioxane has a relatively high melting point. It's about 53 degrees Fahrenheit, which is, for you viewers from anywhere else but the United States, that's about, I think it's 11.8 Celsius. I think that's the exact number, but has a relatively close to room temperature melting point, which means that in theory this could freeze over one night. I'm gonna see one night as I'm going to bed, because here where I live, it is getting down to about 4 centigrade at night, which means that we're approaching the time where this could actually melt in the night. And I'm gonna record a video, and if it does end up freezing over at night, I'm going to record it and show you guys. So it does have, it's kind of interesting here. I'm gonna test the refractive index of some of these. Wow. That refractive index is insane. That's way more than water. Like, you can see how much it refracts it. And it also has, it's kind of hard to see on camera, but it has like this, okay, you can see it. It has like heat wave patterns in it. I don't think that's from the glass. I think that's from the fluid. So that is pretty cool. That is 1,4-dioxane, which is used often as a solvent. It is, I think it's C4H8O2. Or it's also known as diethylene oxide, but you should call it 1,4-dioxane because there are other dioxanes, particularly 1,2 and 1,3, but 1,4-dioxane is the most common. And 1,3-dioxane is really similar, but 1,2-dioxane is pretty different. Then the other thing, we have 20 milliliters of carbon disulfide. It's supposed to be 10. Okay, but it has 340, so that means it's really toxic, really flammable, but thankfully no reactivity like concerns. You can see the warning signs on it, also flammable. So this is going to be really cool, but this is definitely one of the more dangerous chemicals. I will be storing this probably inside of a jar, besides just having it in the bottle, just because of how dangerous this is. But here we have the box. You can see the flammable and, you know, once again, all the warning labels. Is there anything on? No, there isn't. So we're also going to have another difficult little unboxing here. Getting all the tape off. Is that enough? Yes, it is. The tape, once you just get like a little incision in it, it comes apart pretty easily. It's just the initial getting it apart here. It is relatively difficult, I'm not gonna lie. I am definitely getting back to making videos. Like, it's been a pretty long dry spell here. Okay, there we go. You see it. And there is 20 milliliters of carbon disulfide. So, carbon disulfide is a relatively dangerous chemical. It's neurotoxic. It's a colorless liquid, as you guys could see there. Here, let me get this tape off my finger. It is a colorless liquid, just like the dioxane. We're going to do a little comparison of refractive indexes here in a second. But you can see it is also a colorless liquid. Kind of afraid to touch it. I'm sure the outside of it was cleaned. It just is inherently scary. I mean, you guys saw the fire diamond, right? With 340. I can't smell it. That's good. If I could smell it, it'd be a little bit concerning. But here, you can see this right here. There's a small little blue piece in there. I can see it. But other than that, it is pristine. So there's no way I would be able to melt this in my house here. I mean, or freeze it, sorry. Freeze it, I mean, its freezing point, I think, is negative 70 degrees Celsius. I don't know what that is in Fahrenheit, but I mostly use Celsius for this kind of stuff just because Celsius is the temperature measurement of science. So I do use Celsius, and it is about negative 70 centigrade. So there's no way I could freeze this like in my house unless I built like a homemade cryo cooler, and that's a really expensive endeavor that I don't quite have the money for. That's like $800 to buy one, and I definitely don't have the money for that. So I want to do like a refractive index measurement, but I don't quite know how I'm actually supposed to measure it. I can just do a little comparison now. So here we have 1,4-dioxane, carbon disulfide. It's a little bit of cardboard on my table here. Let me just... Okay, so here are the two liquids side by side. They're both colorless liquids, nothing crazy there. We already knew this. They're both completely colorless, clear liquids. It seems like 1,4-dioxane, here you can see with this, that refractive effect, like that, it almost looks pixelated. That pixelated effect is way less with this than it is with this. Like, it's a lot less. But here, we can place these like this, almost. And place the ruler down at the bottom. We'll spin it around. You can see that the refractive effect with the 1,4-dioxane is a lot more than it is with the carbon disulfide. You can definitely see that. Here, you can see that wavy effect too. Over here, it's not as strong. And overall, these are very interesting compounds. The 1,4-dioxane should stay like it is for like pretty much all time. You can see the top here. I'll show you like the bubbles. You can see that, the air pocket in there. Yeah, it is. It's not super viscous. It's like water, and the weight is really similar to water too. But the carbon disulfide here, you can see, ooh, it has like a rainbow effect. That's really cool. I already saw that on the listing where whenever it's turned over, you can see like a rainbow effect, but that is really cool. It's like a thin film interference, and you can just see here, like at the bottom there too. That is really cool, but you can see it's really low viscosity. Like, it has really, really low viscosity. It's nothing like mercury, like low surface tension. This is literally just like water. Like, there's no other way to describe it. It's definitely not water because you can see that the optical effects are not like water, but this is way different from water. This is kind of cool. Really low viscosity, really low surface tension. It's overall cool. But this does react with UV light, so as long as I keep it out of like sunlight or something like that, it should be fine. But yeah, those are the 2 new compounds in my collection. Thanks for watching.